Hello, good afternoon, everybody. It's 14:54 in South Africa on Sunday. I'm Dingaan Mahlangu from South Africa. I just want to show you today how to do geometry notes using the Pythagorean Theorem. So I want to prove the Pythagorean Theorem using the geometry notes in Blender, but I'm going to divide it into three parts. The first part is just to show you the x and the y coordinate and converting those coordinates into areas, and then the second part we will do the r coordinate, which is your hypotenuse, and the last part we are going to prove now the theorem itself. This is for just entertainment purpose, but while you are also learning geometry notes, and at the same time you also may be entertained with the Pythagorean theorem for those who love maths like me. So let's go on. I'm going to use Blender 4.1. If you've got the earlier versions, they will work almost the same way. I don't think you should have issues because we're just straightforward using the common known nodes. So I've opened Blender 4.1. I'm going to delete my camera and my light by pressing X. I seem to have deleted everything. Let me bring back my cube, and then from there I'm going to go to geometry nodes. I want to remove the spreadsheet. I'm only interested in the geometry nodes viewer and a viewport here. So now I can just click new. Now it will give me my group input and my group output for the cube, but I'm not using the group input of the cube for now. I'll use it later. I'm just interested in the group output, and I'm going to press 7 on my num lock. And then if you want to use your normal keyboard, you will first have to go to edit preferences and allow the keyboard to act as a numpad. So, and then from there I'm just gonna go Shift A, and then I'm gonna add the point. I don't want to use mesh line. I want to use the point because it's also part of the learning process, how you can convert points into a line and then into an area. So we'll use these points. I'm going to first duplicate them because I need 2 points to join into to make a line. Shift A, Shift D, and then that's duplicating. But in order for me to join two points or two nodes, I must use join geometry. So I'm going to type join, and then I select geometry. Then I can join these two, and then I can bring them to the group output. You will see now I've got 2 points at the same point. But if you want them, say now I want them, let me go, if I want them at 3 here, I want this point there, and then I can just type 3 for this x-axis. So if I type 3 here, I'm gonna have a point there. Now I want to join this point and convert them into a line. Shift A, and then I just say points to curve, and then if I put that, then suddenly you can see a line here. If you don't see it clearly, but you can see it's overlapping the red. There is a line there that is representing the x-axis. Now the next thing we want to do, we want to take this point and make it a mesh, and then so that we can be able to extrude it into a plane. So how we do that, we just go a curve to mesh. So we changing that curve, we are making a mesh. Nothing is happening because nothing should happen actually, but now this line is no longer a curve, it's a mesh. The next thing, we must extrude it to show that it is indeed a mesh. So Shift A, extrude, and then I type extrude, I add extrude there. Nothing is still happening because now I must extrude with the offset. If I just extrude with the scalar component here, it will try to extrude it on a XYZ plane. For example, if I say a value, I extrude just a value, I put it there, and I extrude the offset, say I say 2, it's going to extrude the edge anywhere in all 3 planes, which is not what I want. I want it to only extrude along the x-axis. So I don't want to do it. Even if I make it -2, it will just extrude it on the wrong part. So I'm going to delete this. I want to extrude it with a vector so that I can extrude along a plane. So I'm not going to use the math vector node. I'm going to use the combine XYZ. So I'm gonna shift A, combine XYZ, and then I put it here, and then I put it there, and then I can now extrude along the Y. If I say -1, for example, it's going to extrude it along the Y -1. But now what we want to do, we want it to always extrude whatever this length is, that the length must always be the same. So it must extrude the same all the time. So whatever this length is, that length must change also proportionally. So to do that, I'm going to shift D to duplicate this. And then what I want to do, I don't even want to type it directly here. I want to type it inside the modifier. So for me to do that, let's first join the vector to the position, and then we are not changing Y, we are changing X. So we want to take it 3 on the X-axis. But now we want this 3 to always affect this -Y. So this Y must also be -3 all the time. So in order for it to go that way, and then I'm just gonna go Shift A and put in a math node that I can manipulate with whatever number. But I'm not adding this time, I'm multiplying. So I want to multiply by -3. And then from there, I'm going to join this to my Y. So it's no longer using this Y, but it's using that node to give me whatever value that I want. So if I take it now and put it in the value, it will always be the same. So whenever now I change, okay, I don't want to change it here, but I can change it here. You will see now it's going proportionally. Whatever I do, it will do on the Y-axis. So, but I want to type it all the time here, so I'm just gonna join the value that I want to change. I'm joining it to the group input. Then now I will change it here instead of there. So now I can change it directly under the modifier itself. So now we have our X-axis. We want to do the same thing with our Y-axis. So what I'm going to do now, I'm going to copy everything from this except the group input and the group output. I copy that, I duplicate it, I bring it slightly down to have my Y-axis, and then now because I want to join these two to have the same output, I'm going to steal again the join geometry. I just Shift D and I put it there, then I pull this, I put it there. So I've got two coordinates on top of each other because I've changed nothing here. But now in order for me to be able to change here, we know that now the Y we want it to appear there, so it must appear along the negative X-axis. So now we are no longer using the Y-axis for the Y, we're using the X-axis. You'll see now it's already showing the sign, but also we need to come here and say this time we are interested in changing not the X, we are changing the value of Y. So if I change the value of Y here, it's gonna give me that. But what I want to do now, I also want it to be able to type it under the geometry node. So I'm gonna take my Y and put it there. So I've got my Y that I can change directly. Okay, now we've got it. We are just slanting it by this -1. So this -1 must be 0 for it to be straight. And now we've got our square there. So now whenever you change your y, it will also change proportionally. When you change your x, you also change it proportionally. So far, I just wanted to show you these x and the y. So in our next session, I want to show you that now when you have x squared plus y squared, we are going to get r squared. So that will be in our next session too. Hope you've enjoyed this so far. Let's move on. See you in the next session where we're going to do our r squared. Thank you.